Hello, welcome to my talk. My name's Bryan, and I work at the Microsoft Threat Intelligence Center. What I'm going to talk to you about today are some of the challenges we faced when building Jupyter Notebooks for security analysis and sharing them globally with all our customers. The challenge my team was presented was how to share Microsoft threat hunting and security analysis knowledge and expertise with our customers via a new cloud service we were creating called Azure Sentinel. The solution had to be scalable from our small and medium-sized customers right up to the very largest enterprises. It needed to work for a range of different teams with different capabilities, experiences, and data sets. The solution we came to was to use Jupyter Notebooks for part of this. Embedded within the Azure Sentinel product, we have a number of notebooks that we've created to help and assist analysts in a range of security investigation and threat hunting tasks. You can see here a number of the notebooks that we've created as they're presented to the customer via the portal. I'm not going to go into the technical details about this integration or these notebooks here, but you can go look at this online. It's available to anyone. So the first challenge we faced was that notebooks are hard to share. Now you might be thinking that's not true. It's very easy just to share a notebook file. But what I'm talking about here is that notebooks are hard to share when you want to share a templated notebook that can work in a range of different situations, environments, and data sets. Typically, we share notebooks that are designed for a single environment, a single fixed data set that we often reference in the notebook itself, or that are completed just to kind of show the working and output. Again, we didn't have any of those capabilities or possibilities when creating our notebooks. So our solution was to take as much code as possible out of the notebooks and instead move it into Python libraries. We created two libraries, Mystic Pi, which handles the fundamentals of what we're doing in the notebooks, data collection, authentication, basic visualizations, basic analysis. And then more recently, my colleague Ian has created Notebook. Think of these as 3 or 4 cells combined into a single object that can be called with a single line of code. Now, the value of doing all of this is it meant we kept control of the code. So we can update the code in those libraries with new fixes, new features, new capabilities, whilst allowing anyone who's running that notebook to gain the benefit of it, so long as they have the latest up-to-date package. Now, obviously, occasionally breaking changes are going to break the notebooks. We share all our notebooks via GitHub so that people can always pull down the latest version. But that on its own isn't enough, simply because people will pull notebooks down from GitHub and run them in their local environment without necessarily checking for the latest version each time. However, by building into the notebooks an update for the libraries each time, we can ensure they've always got the latest and current code. Challenge 2 was that we can't write the answer for people. Again, these notebooks needed to work for a range of scenarios where maybe a threat does exist, or maybe it doesn't, and we're trying to find out. So we can't just give people an answer. We need to focus instead, we need to focus on the process and the techniques people follow and allow them to find what they're looking for. So to do this, what we did is focus on common techniques that we use time and again in investigation or hunting. One example was this interactive timeline that we built using Bokeh, and we use in many of our notebooks. This allows us to visually represent data and allows the user to spot the anomalies and differences that might be of interest, rather than us just trying to find them in the data itself and presenting it to them. The second piece we've done, and my colleague Karishma, who's a data scientist on our team, worked on this, was to create anomaly detection capabilities that work with a range of data sets and that are customizable. So people can go in and change thresholds, change settings in order to suit it to their environment and their data challenges. As you can see, we also use that notebook timeline again just to allow people to visually see where anomalies are occurring and help them better pick out for themselves where the areas of security of interest are. Our third challenge was that notebooks are a bit of a barrier to entry to many security analysts. Typically, analysts are used to using pre-built enterprise tooling rather than having to code stuff themselves, and they might not be particularly familiar with some of the programming languages used in notebooks. And presenting just a notebook full of code for someone to run can often be quite daunting. Our solution to this was to try and make our notebooks as familiar as possible to them. We make heavy use of IPython widgets in order to replicate an environment they might be more familiar with. For example, we have widgets that allow them to pick time windows, text boxes to allow them to enter values to look for, and drop down and other selection boxes to help them through. What we've also done is hide as much of the code as possible, as I said before. This just makes it a bit less daunting when you're looking at a notebook for the first time. We also made a big investment in documentation, both on the technical side and the procedural side, and also heavy amounts of markdown in our notebooks so people can follow along and run them even if they're not familiar with notebooks at all. We also created a number of materials, including videos and documentation, about how just to get started with notebooks for security investigations. Our next challenge was that everyone's data is different. Azure Sentinel provides a bring data environment for our customers, so our notebooks needed to work with whatever data that customer had. Now, we haven't built them for every conceivable situation, but we've built them to be robust enough that they can handle slight variations in data types, or contents. To do this, what we've done is focused on a common interface between elements. So rather than force all of the data into a common schema, instead we force it into a common format, in this case, pandas data frames. This means that the output of our data collection sections of a pandas data frame and the input of our analysis or our visualization packages are also a data frame. This means that we don't need to enforce a schema, and as long as the data gets pulled back into that data frame, it will be broadly useful by the rest of the elements in the notebook. What we've done is focus on making the elements in our libraries and notebooks as schema agnostic as possible. For example, with the timeline that I talked about before, all we really need to know is the time series that we're plotting and the value we want on the other axis. So rather than hard code that into anything, what you do is you call the timeline, you pass it your data frame, and you just say, this column is your time series column, this column is my value column, off you go and plot it. So as long as the data sets that you have at least a time series and one other column, you can use that feature. We don't need to know what the data is itself, we just need to know those elements. Our fifth challenge is that security is different for everyone. Everyone has different expectations, different challenges, different environments, and different threat postures. How we tackled this issue was by making our notebooks interactive. So as well as having those widgets to pick elements, they have a pick your own story type element where you can select an area to focus on more, and this drives the later stages of the notebook. This means that whilst we're providing a structured process for people to, they're still doing some of the analysis work to identify what is malicious or suspicious for them. What we've made sure we do is have a common terminology and feel across our notebooks so that the output of one looks very similar to the output of another. This means that there's a common and easy understanding across those notebooks as well as analysts are stepping through them. So in summary, what we've really done is focus on the journey a user takes when running the notebook rather than the output of it. We focus on that process and allow the users to have some flexibility, which is a real benefit of using notebooks for security analysis. We've also made it as modular as possible so people can change and adapt the notebooks as they need, but without them having to do that in order to gain value out of the notebooks. All of the ones we present, you can take and run as is and get value from, but you can also easily add in or change elements as you go. Also focused on keeping it as simple and as easy for the users so that new analysts can pick up notebooks and see the value of them. That's involved creating an interface that they're familiar with and investing a lot in documentation about how to use them, what they're doing, and why they're doing it. And then finally, thinking about that sharing and versioning early in the process really helped us. And again, if you're creating notebooks for dissemination outside of a small team, you really want to think about how you're going to handle that early on, because it will become a bigger challenge. Thank you for taking time to listen to my talk. If you have any questions, feel free to reach out to me on social media, and you can find Mystic Pi and the notebooks I talked about during this presentation on GitHub if you want to take a further look at them. Thank you very much.